Thanks for joining us for today's topic. It's an exciting topic. We're going to be talking about robotic welding. So let's let the sparks fly. Join us. Hello everybody and welcome to Industrial Automation. It doesn't have to. In case you're new to our program, I'm Brandon Ellis and I'm your host and also the owner of elliTek. Before we start today's episode, I just want to ask that you consider hitting the follow button and the subscribe button, depending upon the platform you're listening upon. Also, if you're listening on Apple Podcasts and you enjoy what you hear, please go to the show page and scroll to the bottom. Leave us a 5-star rating and review. Now that we've got the marketing out of the way, I want to say thanks for tuning in. So let's get started with today's episode. Hey guys, welcome today to Industrial Automation Doesn't Have To. I'm Brandon Ellis, your host, the owner of elliTek, and I'm here with Miss Beth Elliott. Hey Beth.
Hey Brandon. Hey everybody. How y'all doing?
So, we're back at it.
Yes.
What's this, episode?
It's episode 4.
4.
Yeah.
Number 4.
Yeah, I don't know if anybody, if you guys listened to the last episode about doesn't have to be vague. We talked about some projects and stuff and considerations, but there were mentions of video.
It was vague.
It was vague. There was a little mishap, so that was on me.
Well, you want to tell us about it?
No. I'm learning.
Yeah, there you go. So
we're trying it again today.
We wanted to surprise you guys with the video this season, and the surprise was the video didn't work last time. So we made some references to that.
I tried to get them cut out, but I didn't get all of them.
So we thought it would be interesting for you guys just to kind of,
wander
around, feel yourself around the rooms and wondering why is there no video on this thing. So what are our video streaming services? So I know the ones I know. Certainly we can do video, or we will do video, or this is on LinkedIn, Facebook, and YouTube. Our YouTube channel specifically.
Those are the 3 that I was putting it on.
Yeah. So welcome if you're watching us. Hey guys, you're seeing us in our element, in our environment here in the elliTek web, our podcasting studios here at elliTek, a part of our elliTek University Center. Hey, I want to do a quick little shout out. You were telling me about some of our listeners. She gets to see not who you are, but where you are.
Yeah, that's all we get is location.
and that's really geographically. So, I want to shout out. So we've started building kind of an audience, kind of a hashtag. The elliTek Automation Nation is what we're calling that. So I want to say hello to everyone. We've had quite a few downloads over the last year. I want to thank you all for that. But shout out to the elliTek Automation Nation in Melbourne, Australia.
That's right. Thank you guys for listening.
Good day.
You surpassed it. The last 5 episodes, you surpassed our local listening audience.
Which would be the good old US of A. So yeah, thank you guys. It's very interesting that the reach that we get. Glad you are getting a lot out of the episode. But today is really exciting.
It is.
So go ahead.
All right.
Not just because we have video working.
Well, it's going to be exciting because we're talking about robotic welding.
That's right. So hit us with the title.
All right. It's Industrial Automation. It doesn't have to be boring.
That's right. Because what we did was we welded. So what's the big deal about welding? There's a lot of people that weld.
There are. So why would folks choose a robot to weld over a person?
So robotic welding is the exciting thing that we're doing today. And I'm excited about it because we've been doing a lot of robotic welding with one of our
it's fun to watch.
robotic lines. And so I love welding. I'm not a great welder, but let me tell you something. I can weld a lot. Well, I can weld perfectly if I have a robot with a welder. And so, so why would we do that? Well, we go back to brandology. Which one's brandology?
I don't know.
Brandology.
I thought that was elliTek Automation Nation.
Yeah. brandology. That's the one. So see, I don't know. Can you all see? You can't really see the board. No. I've got a few buttons here, but it's now a thing. I'm not going to label them.
You get what you get.
You get what you get. And so I mess up sometimes. So, hey, you're seeing it here live. This is live action. So, yeah, so when we have to bring out together the brandology of the 4 reasons to automate. And those 4 reasons are quality, consistency. And again, these 4 things, just to review if you aren't familiar with these, it's my 4 things that if you're going to automate a process, and this is with a robot or just with machine automation, whatever.
Automation in general?
In general. So whether it's pneumatics, whether it's electric, servos, robots, whatever, why are we spending the money? Why is this a focus? What can we expect out of automating this process? And it really should fall in, the focus should be at least one of these. Now, the benefits may go outside of one of these 4, but you want your primary focus, your primary reason to be one of these 4, and that's increases in, and not in this order.
Okay.
Increase quality and consistency, decrease in cycle time, or we call that increased production, reclassification of labor, or flexibility, quick setup. So let's talk about those real quickly. Quality, consistency, doing it better. You're going to see what that looks like because a robot can weld better than Brandon. I'm not saying anybody, but definitely me. It can weld better than me. It also can do it longer and those kind of things. So we have decreased cycle time, increased production because we're doing it. It doesn't have to take lunch breaks and smoke breaks and wee breaks and things of that nature. And it doesn't get tired. Reclassification of labor. We're going to talk a little bit about the guy that's actually in the shot of the video that we're going to show. Yeah. So,
are you ready for that?
No.
No. Okay.
but I let it slip. But it's new. It's exciting.
I know. It's not boring.
But for those of you who are listening on the podcast, one of our audio streaming apps, certainly we're going to try and talk. I'll try and be as descriptive as possible. But one of the guys that was involved with this and setting this up is one of our welders. So we're not going to replace him with a robot by any stretch. But he now can help set up robots to weld.
Wow. And he is not a computer person at all.
He is not, and he wouldn't mind me referencing him by name, but Todd is his name, and we love to have Todd around here, but Todd makes it very clear he is not, nor shall he ever be, a PC guy. So he's not a programmer, but we'll talk about why that's possible. The last thing, so reclassification of labor, if we were doing if our business was repetitive welding, you need somebody who's an expert in welding. But quickly, if you use the right parts, if you work with the right company, as Todd showed, you can set this up without even needing the PC, without even needing to be
a computer
guy. And so imagine now, Todd's a good welder. He can weld fast. But imagine if he had 3 or 4 robots that he was running and they're all welding. That's and amazing. He's monitoring them and monitoring the systems and things of that nature. Reclassification of labor. That's exactly what that is. And then flexibility, quick setup. That means a welder can go from one piece to the next, to the next, to the next without a whole lot of changeover or having to rethink your stuff and that kind of stuff like a person would have. So we get close to seeing benefits across all 4, but one of the primary things is quality consistency. And then the number 2, or maybe they're tied for number 1, is decreased cycle time, increased production. So that's why I think folks would use a robot to weld. Cost comes into play. Certainly you're buying a robot, so that's something that needs to be considered. But if your business is consistent welding of parts, and now if no 2 parts are ever alike,
that might be difficult.
That's very difficult. But if you're always welding the same thing for in a production environment, then it makes a lot of sense pretty quickly.
What's the difference? What would be the benefit of a collaborative robot over an industrial robot for welding?
Well, and you've heard me say in the past that I think welding and collaborative robots go together. What is it? Forrest Gump says, like peas and carrots. Is that it?
I don't know.
Anyway, yeah, because well, let me get to that in a second. So industrial robots are very accurate, very quick, things of that nature. And honestly, we have our pre-engineered solutions that elliTek puts together, where we pre-engineer a robot with the base and all this kind of stuff, and safety if you want it, and all the kind of stuff's handled, and we let you take care of the programming and everything. We don't offer one that's all set up for welding, because the two primary industrial robots that we carry, which is Yaskawa Motoman and Fanuc, they actually have weld cells ready to go.
Ah, nice.
And we sell those and support those. And so that's put together, all ready to go. But an industrial robot has to have, good safety.
Yeah.
Because industrial robots
they're not going to stop.
They're not going to stop. They're inherently unsafe as far as humans, and so you have to guard them, hard guarding, things of that nature. And when you're welding, whether it be collaborative or industrial, you also have you have to guard passerbyers, people other working in the vicinity, because of the arc flash.
Yeah.
The weld arc light is like looking into the sun, and it can damage your retina. Can cause short-term damage, long-term damage, and so that's the reason welders always wear masks and things of that nature that have the dark glass and that kind of thing. And so you can do this with weld curtains or a solid barrier or something, but you're gonna have to do that no matter if it's industrial or collaborative. Collaborative brings about some interesting things, though. Remember, and again, this is why I think collaboratives and welding go together well. Collaborative robots. We did an episode on when I talked about people say collaborative robots are slow.
Yeah. Oh, yep.
Well, they're slow because you're having to do if you're going to truly try to, which I've never seen. Get your glasses. Clink, clink. I have never seen anybody use a collaborative robot 100% collaboratively, which means that the force sensors are all that you're relying upon as far as safety. And if you do that because of your safety, you still have to do a safety analysis, a risk analysis. You calculate, it really comes down to whatever you're carrying, what's the pounds per square inch of the force and that kind of stuff. If it's a really wide, blunt object, then you disperse that pound, any force across a larger area, so more square inches. But if it's a really pointy object, then you're concentrating that, and so you're going to have to do at least a safety light scanner, or some types of light curtains, or maybe even some light duty guarding, hard guarding in some sort. So you're going to have to guard it. Mm-hmm. If you don't, then what you have to do is reduce the speed. So remember, people saying collaborative robots are slow. They're slow because you're not guarding them correctly. You have to go slow. Well, with welding, with the exception of two moves, moving toward the object and moving away from the object, you probably want to do those pretty quickly. But when you're welding,
it's pretty slow.
You have to go slow.
Okay.
And so that's why I think it kind of lends itself to collaborative robots. The other thing is collaborative robots. Did I mention that Todd hates PCs?
Yeah.
We have a video.
Yes. All right.
So
we're going to try this out.
Pull that up.
All right.
So here's the video
It's
elliTek
just
presents.
starting, yeah.
So we're using a Hanwha HCR5A, one of our collaborative robots. And honestly, the welder we're using is just an off-the-shelf. It's a manual welder. We just have bypassed, and don't do this. We can do this, but you want to use a real welder that's made for automated welding. But if you're looking at the video, it's making a pass. It's a linear pass in this shot. We did some curved passes, some arc passes and stuff like that, doing some curved welds. But this is a long linear weld. And the guy there to the right,
that's getting sparks all over him
with the weld helmet and nothing else. So don't get on to me about
He's
safety.
a welder. He knows what he's doing.
He's supposed to have his weld jacket on. But he's there watching the weld, and he's at a
Look at those beads on there.
Yeah. So it made a perfect fillet there between two pieces. And so it was exciting to see. So if you're watching this, you can kind of get an idea of that. I'm gonna rewind that and just see that. There we go. Yeah, so
Take
you're
a look
looking
at that.
there.
Oh, doggone it. There we go.
Click the pause button.
Where is the pause?
Right there.
Okay. There we go.
Yeah, there you go. So they're stacking dimes. So I got in a conversation yesterday with one of our mechanical engineers, Joe, and I said laying dimes, and he said no, it's stacking dimes. So we got on Google and got in a little bit of what is it, and the term is correctly stacking dimes, but then everything that there was some things on Google where people had used dimes to indicate what it looks like, and it's dimes that are laying on their side, kind of interleaved, so they're one on top of the other.
Okay.
Well, I'm like, those dimes are laying upon each other. Stacking dimes is what you do when you go to Vegas and they have the chips. That's a stack.
That's what I was thinking, because when you stack something, it's
stacked.
Yeah.
One atop the other. But anyway,
it's vertical, not horizontal.
We decided that technically laying dimes and stacking dimes, but that stacking dimes wins as far as the cool factor.
Okay.
So it's more cool to say. So if you're out there welding and you don't want to be like me and sound like you're an idiot, don't say laying dimes, say stacking dimes.
Stacking dimes, okay.
So anyway,
did you want to go back to the video, or?
Well, we'll pop back to that picture. Okay. You can kind of see some of the stuff there.
There we go. Oh, doggone it.
Yeah.
Excuse me.
And she's backing it up. She's working the controls. So
oh, doggone it.
The cool thing is, I'm not doing this. Beth's controlling this.
Sorry, guys.
And so I'm getting to watch. So video means new software as well.
Yes.
So I get to handle all the sounds. Woo! But she takes care of the video, so it's a good marriage there. But we're looking at that weld. It filled in very, very well. You can see, we call that the penetration marks. You can see on the sides where the depth of penetration, you're seeing the heat through the part. And so it's kind of darker. Now, we set this up, and for those that are welders, they're looking at this and saying, you didn't clean your parts first. And you're exactly right. We kind of weren't so worried about making, this is just a couple pieces of steel. We wanted to see what the robot would do. We were focused on the welding and not really the prep. And so there's a little bit more, some of the impurities you can see coming out there, but it's still a very good weld. Nothing a little wire brush wouldn't fix. But the fact that it took us about 5 minutes.
Wow.
To set that robot up to do that weld. And it's done. And, we don't have a fantastic, we just had a very makeshift fixture, but if you had a good fixture that would reliably place the part in every time, then it's just a matter of place it in there, hit start and walk away. And so even with manual tending, you can have just this stuff working over and over and over again. Again, number 2 in the 4 reasons to automate: decrease cycle time and increase production. And so, which that leads to, now that you got your robot welding, you just stick a robot out there tending.
Oh, okay.
So when the welding robot gets done,
one can do and hand it the parts.
One puts the part, takes the finished part out, and then flips around with the other gripper on the other side, lays the right parts into the fixture, and gets out of the way, and the welding robot comes in and starts welding it up. So while that robot's discarding or placing the welded part, it goes over and gets the other 2 parts for the next load. And as soon as it's done, pull that part and put those parts in, and you just right down the road.
Nice. That's automation right there.
That's automation. That's right. So that's that. So this is, I guess, the question that you would ask is, why would folks use a robot to weld instead of a person? Well, you use a person to get it set up. Todd set that up. But then once it's done, the person's just kind of managing at that point. And they could be managing multiples and multiples and multiples of reclassification of labor. And you get consistency, you get quality, you get decreased cycle time. That comes down to ROI, return on investment, which that comes down to cha-ching.
You don't have your cha-ching button, do you?
I don't. I need a cha-ching. I'm going to have to work on my... Now that you're one-upped us with the video, I'm going to have to get better sound effects.
Hey, it took a week or 2 weeks to get to it. So how do the types of materials affect the robot welding application?
Well, in that video, we're welding just regular steel, cold rolled steel. And you're right. There's different types of materials or metals. So you certainly, that folks are familiar with them would be welding. Just regular steel of various types. I'm kind of categorizing them all in just steel.
Okay.
There's all kinds of different types of steel, from cold roll to tools.
I remember that from the 3D printing podcast.
Tool steels and all this kind of stuff. But normally you wouldn't weld tool steels, I don't think. You'd normally weld cold roll or something along those lines. But also there's aluminum.
Okay.
So, and then another common one is stainless steel. So stainless steel has a different makeup as far as what's in it than just regular steel, which is the main reason they call it stainless. It's got I think it's chromium. I think it's increased chromium. I think it's chromium. Sorry, I'm not a metallurgist. I program robots. But and I'm certainly not a welder. So Todd probably could tell us. But I think it's chromium that's increased chromium or high chromium that's inside the mix that creates stainless. And so chrome doesn't rust. Regular steel has got a high iron content, and so iron rust. And so those are some things that come down. But when you weld them, let's talk about, we've got a graphic there.
Okay.
So I want to go through and this is just a standard MIG gun. And so I think, here it is. So looking at the different components, and this is not going to be Brandon is an expert kind of thing. But really what you've got is a piece of wire coming out the end. The end is down there with the welding, where it's labeled on this graphic, the welding electrode. And so that's the end. That's the part where that's where the fire is.
Okay.
And so going back to the welder, inside of that, it's a hollow tube, and this wire is fed down there. So that type of wire, what the wire is made of, has to do with what kind of steel or material that you're welding.
Okay, so you have to have the type of wire to go with the type of steel.
That's right.
Okay.
So what we were doing when we were welding, MIG welding the steel on those brackets, you could not use that same wire to weld aluminum.
Okay, because it wouldn't stick.
They're dissimilar.
Okay.
Well, they just don't go together.
Okay.
And so you would need aluminum wire to weld aluminum.
Okay.
Because what you're doing is, in a MIG application, specifically in a MIG application, there's different types of welding: arc welding, stick welding, TIG welding. I put those two in the same category.
Stick and TIG.
Stick and TIG. TIG welding, you're actually creating a spark, if you will, an arc between the material and the end of a little thing on the end of we call an electrode on the end of the welder.
Okay.
And that gets the material really hot, and it becomes molten, creates a puddle. And then you have just a little stick of the same type of material, aluminum if it's aluminum, steel if it's steel, that you just dab in, and as it melts, you begin to fill, add more material, more metal, and it goes from liquid. When you get away, it goes back to solid, and you've blended it together. Stick welding means we put the electricity on the thing that your stick, in this case, and so there's an arc between the end of the stick and the material, but it's also melting away the stick.
Okay.
Because you're passing current through that into the part. Remember, the part's grounded.
I hope so.
And so, it has to be grounded. You got to complete the circuit. And so in MIG welding, which is usually for steel, that's what we were doing, but it can be for aluminum and also for stainless. You just use a different type of gun, but it's really controlling how you control the wire, what we call the wire that's coming out. We're actually charging the wire. It's according to how you're doing it. Sometimes you charge the wire positively and you ground the part. Sometimes you put the charge on the part and ground the wire. But you still have to be one or the other.
Okay.
But when that wire, just like stick welding, when the wire touches the grounded part, you create a short circuit basically, and it becomes molten. And there's a lot of heat. There's two ways to do standard MIG welding. You can have gasless or gas. In our case, we're using a shielding gas. So what that means is you have something there that keeps it kind of in control. And so the shielding gas doesn't let oxygen come in, so that you just end up with a bunch of bad stuff in your weld. So it becomes more of a burning at that point as opposed to welding if you don't have the shielding gas.
Okay.
Just makes a mess. And so shielding gas goes around it, so it's coming out of the nozzle on this graphic. But this little thing that says welding electrode,
oh, okay.
Yeah, that is the wire.
Oh, on the end of it. Okay.
And so when that wire touches the grounded or positively charged, opposite charged material, it's a short circuit. And everybody's kind of seen a short circuit, right? It's like a lightning bolt. It creates an arc. And so you're controlling that arc that's heating up your materials that you're coming into contact with very quickly. It's also turning the wire into a molten material. And they begin to blend, and that's how you weld. You're blending metals together. So you're not burning them.
Just blending.
You're melting them, and they flow together.
Okay.
And so that's how this works. Now, let's go to another graphic here.
All right. Bear with me a moment. Let me make sure I've got... Okay. All right. Yay.
Yeah, so turn that. Let's see. Good job, man. You got the video to work.
I think we got it. It might give it a second.
Yeah.
There
you go.
All right.
Okay, so this is just another view, and you can see the electrode wire, the shielding gas there, the weld metal, and all that. And so the welding arc, that it's kind of, I didn't draw this picture, so shout out to whoever did, but it just is creating this arc, and that's kind of what's going on. So, but the wire is the key. Okay, the wire, the electrode wire is what type of wire it is has to match the material that you're welding.
Okay,
that's the long and short of it. So when we're doing that with the robot, we may have to have an end of arm tool change.
Oh, okay.
So
with a quick end of arm tool change,
it can be quick changing, and usually this goes through back to the. It has to also work in terms of the welder, whoever is supplying the automation welder.
Okay.
And so usually we use there are companies that make automation grade welders for robotic welding.
Okay.
And so if they're doing tool changes, it has to know what's going on, because there's also different settings that come up. So how fast you're feeding the wire, what's the amperage that's going through, those kind of things.
Okay.
If you're welding thick material and then suddenly you're welding very thin material, you have to turn your amperage down, because it'll just be too much heat for the thin material and it'll just disintegrate. And so remember, you don't want it to just disintegrate. You don't want to burn it. You want it to flow and just be in a molten state, but a controlled molten state.
Okay.
And that's Brandon's vantage point of welding.
All right.
So hopefully that's helpful. But that's what's happening. And so I wanted the graphic here for those watching the video to kind of see what we're talking about if you're not that familiar with a welding gun. Okay, so back to us.
Oh, so why isn't it reasonable for folks to get a robot and off-the-shelf welder?
Well, we were using an off-the-shelf welder, just a manual welder. It's not reasonable. Well, it's not and also I'm impatient. It's not a reasonable thing. So what we did, and don't do this. This is some of the things that the crazy experts can do, and we are crazy experts. I took just one of our standard welders, off-the-shelf standard welder, and that's a manual welder. It's got the trigger on it on the handle, and so it's for manual MIG welding. And I bypassed the trigger part and let that go down into the robot. We also had just because we're safe, we had a little override button as well. Just because if something didn't go right, I I didn't want to mess up my welder
Yes.
or my robot. And so, but those are the things that you have to do, that we had to do because of that. So it's not feasible. It's not something you want to stick in.
Well, Todd had to sit there and hold it, didn't he?
That was my safety. So if we saw something going wrong,
he could just let go.
He'd let go, and it would extinguish the arc.
Yeah.
Because you have to an automation grade welder, okay, is going to do things like, number one, arc sensing. So if I talked about the wire touches the part and it turns into an arc. Mm-hmm. Well, robots don't have eyes,
Nope.
Typically, and so it doesn't know if maybe the part shifted or something, and suddenly usually if a welder's going along and they get too far away or something's not right and the weld extinguishes, then they know, oops, got to stop, go back, hook up with where I left off and continue on, or do something, right? Okay. Well, the robot wouldn't know.
Okay.
Unless the welder can tell it. And so with automation grade welders, they have arc sensing, so they can tell if the arc extinguishes or not,
and alert the operator.
Alert the robot.
Okay.
Alert the robot.
Oh, okay.
And then the robot can act on it in some way.
Oh, okay.
They monitor wire feed to make sure you're not out of wire.
Yeah, that would be important.
That your consumables are good, so your gas isn't getting too low or empty. I mean, all that kind of stuff comes into play. That the welder, an automated welder, can do, and then can collaborate that with the robot or tell the robot that's going on.
Okay.
The other thing that they offer is some cool little things for what I call gun prep.
Oh yeah,
and
what's
so
that?
the MIG gun, or the whether you're doing MIG or a spooler or whatever, you need so much wire sticking out the end.
Okay.
If it's too much, you can't get down to where you're supposed to on your part, and robots don't know that that's sticking out. So a lot of times before you start a part, or every so many parts or something like that, a robot may come into this thing, and it may even be. I've seen some that are really, really top notch from welding companies that they can sense how long the wire is.
Okay.
But usually we just move it to a fixed position, and there's a cutter that cuts the wire. The wire goes down and it's discarded in some ways. It can be cleaned out easily. Those kind of things, those assemblies are kind of part of what a lot of the robotic weld companies sell. And then the tool change, we talked about the gun head changes and stuff like that. Now, most of our customers, if you're doing a whole lot of steel and you're doing just as much aluminum, usually they just do two cells. And so if you want two robots,
so you don't
two
have
weld
to
setups.
do this changeover.
That way you don't have all the changeover, because changeover tooling is another cost to figure in. Especially if you're doing, but if your throughput requirements are roughly the same between steel welds and aluminum welds, it justifies to have two going at once. Now, if you only do, 3 aluminum parts to 10,000 steel parts, maybe not. But all those things need to be taken into consideration.
Yeah. So, what considerations need to be made when you're working with an automation company to implement a robotic weld work cell?
An automation company like
elliTek, for instance.
elliTek Automation Nation. Woo! Yeah. All right. So, well, like I said, don't use an off-the-shelf welder. You're gonna have to get an automation grade welder, because you need that collaboration between the welder and the robot.
The collaboration meaning that they can work together.
That they can talk.
Okay.
So again, if the robots that the welder says, okay, everything's good, and then the robot starts the weld, and while it's in the middle of the weld, the welder's saying everything looks good. If the arc extinguishes, if the wire runs out, if the gas runs out, if something goes wrong and causes that arc to go away, or not be able to make a good weld, you need to let the robot know so the robot can stop. Mm-hmm. What you don't want is you don't want to keep feeding wire and it not be part of a weld.
Yeah, that's true.
Those kind of things. And you also don't want to make bad parts.
Yeah.
And so you need to have that collaboration. That's what I'm talking about. They need to have connectivity, even if it's just discrete I/O. you need to have some type of connectivity.
Okay.
You can also have some programming interfaces if they're partnered in with the robots. But that really comes down to the robot manufacturer working with the welder. Which, the other point is, the robot manufacturing has to say, welding is okay with my robot. There's many out there that say, you'll void the warranty if you try to hook a welder up and mount it to this robot.
Oh.
So you really need to work with a company that knows their stuff,
types,
that they know these go together. And then the thing I've seen the most is manufacturers say, you can spot weld with this robot. Spot welding is different than MIG or MIG type welding with aluminum, stainless, or standard steel, because all those are running a charge through a wire into a part that is either positively or negatively charged.
Okay.
Spot welding, think of very, very large tweezers. And when I say tweezers, they come out and they kind of come down to a point on either side. So when you squeeze them, those 2 points come together. And so what we do in spot welding, and you can do this on a robot, in fact, you see it a lot in the videos. We don't have any videos of this, but if you see videos of the car manufacturers with the robots coming in and all of a sudden you see a bunch of sparks fly off. Uh-huh. Usually that's spot welding.
Oh.
And so you got now your two sides of your tweezers. One side's positive, one side's ground. So opposite charges, and they're squeezing between two pieces of metal. And then when they pass that current through, it's kind of a quick passive current. It's heating up the two pieces of metal between the fingers.
Okay.
But the electricity is really only passing between that little
piece of
between the two fingers.
Yeah. Okay.
That's your positive and negative. When you're doing MIG type welding, the gun is where it is, and the part is where it is, and they're the different charges. So if for some reason you did not ground it properly, the electricity could decide to take that the shortest path to ground is through all the motors and sensors and encoders and all the position sensors and everything through the robot.
Oh dear.
And that's why it needs to be designed for such.
Yeah.
And so Hanwha does do that. That's the reason we're using Hanwha for welding, as does Yaskawa Motoman and Fanuc. They're set up for that as well. But there are some out there that are not.
Okay.
And so you need to check with your manufacturer. You don't want to void your warranty. You certainly don't want to fry a robot.
Oh goodness, no! Not when you're trying to save some money.
The other thing you need to take into consideration is safety. We talked about that briefly. Industrial robots always have to be guarded. Collaborative robots, while they tend to lend themselves to welding applications because welding's typically slow, you still have that movement to and from. You've got things you got to do there, and so you're still going to have to do a safety analysis on that as well. I think the guarding could be less substantial, or again, safety scanners and things of that nature. But you're going to have some kind of guarding safety that has to come into consideration. And then the only other thing I'd say is work with a quality automation company and automation experts such as
elliTek.
elliTek. www.ellitek.com. But that's basically it. Hey, throw that video back up.
Oh, yeah. Okay, just one moment.
That's why
I'm going to have to rewind it real quick.
Yeah, go ahead.
Okay, and here we go.
There it is. So elliTek presents the Hanwha HCR5A welding application featuring Todd Ader. So yeah, the video kind of started. It actually moved down to I was there when it happened. I was cheering it on. It actually did move down to the part, but the video has been edited a little bit to be shorter. I shortened it.
I couldn't. You couldn't see it.
Oh, you couldn't?
Yeah.
Oh, I see. So we've got to work on the camera angles. But certainly you can see what's going on, and Todd's just kind of watching it lay down there. That's exciting. So if you're not getting to see the video,
it's up on YouTube.
Yeah,
it's already posted on YouTube.
Oh, it's already there.
Yeah.
Well, good. So now you're kind of seeing it, and then there's a shot of it after cool down there, the parts that we made. So yeah, Hanwha Robotics. So shout out to them. I love their robot Man, it's so easy. And again, to set
Todd's
that up,
not a programmer. He's
No,
not a controls
not at
engineer.
all. And so I had my welder who hates PCs. I had my sales engineer out there, and myself, and we set that whole thing up, and we did that weld, and it was less than 5 minutes.
Yeah, that's fantastic.
And that really is fantastic. That's the exciting part.
It's not boring at all.
No, it's not boring, especially when you can make firemen.
That's right.
That's right.
Yep.
Hey, guys, I want to thank you very much for joining us for today's podcast.
Absolutely.
Again, we've just been having a ball doing this, and so the video is going to add even more
It's going to add another dimension.
That's right.
Yep.
We'll have costumes. What? Who knows?
Halloween is coming
That's
up.
right. That's right. That's right. So,
I want to see you with hair.
yeah, there you go. Yeah, maybe I'll pull out my Bubba teeth for that. Big mullet. The mullet's making a comeback, you know.
Yeah, there's two kids in Knoxville, Tennessee that are in competition for the best mullet.
Oh, yeah?
Yes, there was a gentleman in Campbell County, just up the road from here, that won.
Oh, he won it?
Yes, for the adults.
All right. Hey. Yeah, a mullet.
Yes.
So, let's see. No, that's the wrong one. Mullet. Yeah.
That's the mullet.
That's the mullet. That's the mullet tune right there. So, yeah. Who knows what we'll do? We'll have fun no matter what.
Yeah. Thank you for joining us, and thank you, Brandon, for your insights.
Well, okay. So call us.
Oh, yeah, that's right.
865-409-1555 if we can help you. Check out our website, www.ellitek.com, ellitek.com. And, of course, we're all over LinkedIn, Facebook, Twitter, Instagram.
I think that's it.
Yeah,
that's it right now.
Yeah. So and we're on video.
That's right.
Coming to you live. So live action. So thank you very much again for joining us. Hey, leave us comments. If you like what you hear, hit that, smash that like button, subscribe to the channel, give us a 5-star rating in the Apple.
And if you think that somebody might enjoy this program, share it. Let them know about it.
Yeah, certainly. And keep those comments coming. We've loved talking with you. And again, a big shout out to elliTek Automation Nation down in Melbourne, Australia, and across this great globe.
Absolutely.
Guys, thank you very much. Have a great day. We'll see you.
See you, Brandon. See you, everybody.